Good morning. Today we are going to take another very important question of the miscellaneous exercise, question number 18. Now the question says that show that the height of a cylinder of greatest volume which can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3 that of the cone and the greatest volume of the cylinder is 4/27 pi h cube tan squared alpha. So basically what is given is, this is a question which is different from all other questions we have done so far. So here we are given a cone and we are given a cylinder which is inscribed in this cone. So this is the figure which is given to us, and what we are required to do is we have to maximize the volume of the cylinder. So to maximize the volume V of cylinder. Now what is given to us is given a cone of height h. So since the cone is given to us, it means that h is equal to constant. Also the radius of cone is also constant, and let it be equal to r, say. Okay, so we are assuming it to be r. So what is given to us is now this is the radius of the cone and the height of the cone is given to be h. Okay, now let's name it first. Okay, so let us call this A, let us call this B, let us call this C, let us call this D, let us call this, join this and this point as E. Now as I had said earlier also, this is a special type of a question. Now here as you can see, these triangles are similar, that is AED and triangle ACB are similar. So we are going to use the concept of similar triangles, and in case of similar triangles we know that the sides are proportional. So we will make use of that concept in this question. Now we are given the semi-vertical angle is alpha. So the cone is given, so h is given to us, and r we are just taking from our side, that because r will be fixed, so let it be r. Now let us call this edge as f. So let the radius of the cylinder be small r, and we have let the we have to find, so let us take this side AE as small x. Now so that height of cylinder equal to this h minus x, so equal to this EC equal to h minus x. So one thing is here. Now what else is given to us, that this r, so let radius of cylinder be equal to small r. Now small r also we want to find in terms of h and x, so that the entire question comes, or the volume can be expressed in terms of small x. Okay. Now since triangle AED is similar to triangle ACB, okay, therefore sides are proportional, and so we have ED upon BC is equal to AE upon AC, that is ED upon BC equal to AE upon AC, which gives us, but ED is equal to small r and BC is equal to capital R is equal to, this small distance AE is small x and this big distance is given to be h. Now from here we are able to find, since we are wanting to express r in terms of x, so we will solve for small r as r over h into x. Clearly in this r upon h is a constant and x is the only variable. So we have found the radius of the cylinder also in terms of x. Therefore volume of cylinder V equal to pi into radius square, r square is radius square into height, okay, is equal to pi into, now pi into radius is r square into h is the same as EC, okay. So r squared would be r squared over x square into x square and EC is h minus x. Now let's solve it. So we get V is equal to pi r square over h square, this is all constant, into h x square minus x cube. Call it equation number 1 and this has to be maximized, okay. So for maxima or minima, differentiate V with respect to x. So we get dV over dx is equal to pi r square over h square 2hx minus 3x square, okay. Now you can open it up as 2, here we get 2 into r squared, this h, one h gets cancelled, into x. So we get 2 and pi is also there. So 2 into pi into r square into x upon h minus the other term comes out to be 3 into pi into r square over h square into x square, okay. Now this is what we have. Now putting dV by dx equal to 0, we get, now this term is 0, that is 2hx minus 3x square equal to 0, that is x times 2h minus 3x equal to 0. This gives us equal to x equal to 0, which is not possible, or 2h minus 3x equal to 0, which gives us x is equal to 2h over 3. Now corresponding to this we want to check for maxima or minima, so we want to find the second derivative. So for maxima or minima, differentiate dV by dx with respect to x. So what we get is d2v over dx2 is equal to, now dV by dx is equal to this. So when you differentiate this with respect to x, you are left with 2 pi r square over h, and when you differentiate this, so minus 6 pi r square over h square into x, which is less than 0 when x is equal to 2h by 3. It implies maxima. So thus we get corresponding to x equal to 2h by 3, volume of cylinder is maximum, okay. Now what is required here is, there are two parts to this question. One is that we have to find the height of the cylinder is 1/3 that of the height of the cone, Okay, so now we had got this the height x comes out to be 2h by 3. Therefore, height of cylinder equal to, we had it as h minus x, which is equal to h minus 2h by 3, which is equal to h by 3. So, clearly we get height of cylinder equal to 1 by 3 height of cone. Okay. So, first part is proved. Now, the second part is we have to find the greatest volume or the maximum volume. Now, maximum volume of cylinder is equal to, V is equal to, V will be equal to pi r square over h square into x square into h minus x. This is the formula, but x is equal to 2h by 3. It implies that maximum volume V is equal to pi r square over h square. In place of x, we will be writing 2h over 3. So, 4h square over 9, and this is h minus 2h over 3, and this gives us maximum volume equal to V is equal to pi r squared upon h square. Now, this h square and this h square gets cancelled. So, we get this, or let me write it again. So, we get 4h square over 9, this gets cancelled, into here we get h over 3, and this comes out to be 4 by 27. Now, we are left with pi, then r squared, and then we have h. Okay. So, maximum volume V is equal to 4 by 27 r squared h. But in the question, we are expected to find the value of volume in terms of the slant angle alpha. Okay. So, we have, that is called as the semi vertical angle alpha. Now, so now since we want the result in terms of h and alpha, okay, therefore writing, so we need to remove this r square and write it in terms of alpha. So, writing r in terms of alpha, we get, now if you just see the figure, alpha is there, and here we have this whole thing is r and this whole thing is h. So, we know the opposite side, we know the adjacent side, and we know alpha. So, clearly tan alpha equal to r upon h, and so we get tan alpha equal to r by h, which gives us r is equal to h tan alpha. Substituting in the above expression, we get maximum volume V is equal to 4 by 27, r will be h squared tan squared alpha into h, and so we get maximum volume V equal to 4 by 27 h cube tan squared alpha, hence proved. Thank you.